All right, cool. So our next speaker, he is the fifth generation Frederick Augustus Thayer, making him Frederick Augustus Thayer the fifth. And when he comes out here, I want everyone to sing happy birthday. Frederick, come on out.
I do want to say there are at least two other people in the audience who had a birthday yesterday. So happy birthday to both of you all. It's a great time to have a birthday. So thank you, everyone. Today, I am going to be talking about defending your data when best practices don't apply. So first, I want to give just a little bit of, well, maybe I won't. I want to give a little bit of an intro of who I am and what it is that I do. Okay, we're working. So my name is Frederick Thayer. I am a data scientist at Naval Aviation, or NAVAIR, proposal analysis team. We are a team within the government, and we are part of NAVAIR's procurement group. So this is the group within Naval Aviation that actually works to buy anything that flies off of anything that floats. So we actually work with contractors to negotiate cost to buy an F-35, a missile, whatever. And so our team was tasked with modernizing NAVAIR acquisition. So basically, we are looking at new methodologies and technologies to take the existing way that we would estimate cost and come up with positions and negotiate with the contractor and bringing it into more modern times. So now we're not just using Excel, we are creating Tableau dashboards and, of course, R applications. So we maintain a number of various R-Shiny applications. We're doing some Python, but really we're a data-driven data science team. And I mention all this because I'm going to say something that is going to undermine all of the credibility that I have. And that is, I have fit a simple linear regression to 3 data points. 3. And I use those 3 data points to support a negotiation worth $500 million. Unfortunately, I'm not alone in this. There are many, many examples. So here are just a few of my favorites from our database of all of the negotiations that our team has supported. We have a nice $280 million deal with a regression run on 6 data points. We have a $930 million deal run on 7. And worst of all, a $1.2 billion with a B, deal run on 5 data points. Now, I know what you're thinking. Frederick, are you just cherry picking the worst examples that you could come up with to make us all cringe? And unfortunately, no. So here is a visual of all of the deals that we have supported on our team. In blue, we have kind of a histogram of the various frequency that the number of data points would have versus the average contract price. So as you can see, a vast majority of our deals and negotiations are run on fewer than 10 data points. And that's also where some of our highest average costs are. So sometimes we have more, but it's not really worth that much. Now, before you throw your rotten tomatoes and chase me out of here with pitchforks, I ask you just give me a moment to kind of talk about why. Why do we do this? Why do we have all these terrible modeling techniques and practices? Well, the real world is not going to wait around for us to get enough data. And that $500 million deal, it was going to be executed whether I performed analysis or not. It was just going to probably cost the government a whole lot more money. So in these scenarios, even if you only have 3 data points, 10, 20, it's important to still be thorough in your analysis because, again, these sort of things are going to happen. So there's a lot of talk about best practices in data science. You'll see a whole bunch of lists out there. This is just one that I kind of found that I thought looked good. And what I'm going to do is hone in on a few key ones and talk about how you can sort of subvert them, why you might want to, and how to defend your analysis when you do. So the 3 that I'm going to focus on are getting enough data, cleaning your data, and choosing the right algorithm. So going into the first one, That is going to be getting enough data. Now, this is the best practice that I flagrantly disobeyed in those opening examples, so it seems like a pretty good place to start. So what do you do in the scenario where you've looked at all of the places that you can get data and you have found nothing but the absolute worst garbage trash that there is? Well, you really need to become an expert on the data that you do have. And so I have a few questions that you need to be able to answer, or you can ask yourself to become that expert. First up is, where does this data come from? So in our case, we work a lot with contractor data. So this is data that we get directly from like a Northrop Grumman or a General Dynamics or something like that. And this is audited data, it's certified, so we know that this tends to be pretty trustworthy. We also have a number of independent government agencies that also provide data for us. So this data, even though it may be small, it may be imperfect, we know that it is trustworthy. It comes from an authoritative source. So now that we know that we have data that is trustworthy and authoritative, we need to ask ourselves, is it applicable? Why is it applicable? So for us, we are doing cost estimating. That is trying to project forward how much we think the next F-35 is going to cost. And so for that, we want certified cost and pricing data. So for us, contractor actual cost incurred is obviously going to be very applicable to what it is we're trying to do. So once we know that it comes from a trusted source, that it's applicable, the last thing is, what kind of structures do you have in place for it? So to give an example out of our world, we understand that negotiating a $1.2 billion deal on 7 data points has, or 5 data points, I should say, has like a little bit of risk in it, or a lot. So we have certain contract types that help mitigate the risk. Obviously, that is very specific to what we do, but in general, if you're able to put in safeguards around your data, around your analysis, you can still justify using maybe not the best data. So the next best practice I want to talk about is cleaning your data. Now, I understand that it's really hard to perform any sort of analysis if you don't do any data cleaning, and you're very right about that. So to kind of give an example of what I mean by not following the best practice and not cleaning your data, I'll give you an example of something that has actually happened. So a separate deal that I was negotiating, we were working directly with a subcontractor, and they provided us a raw data dump from their enterprise reporting system. This is great. We get a lot of data at a very granular level of detail, and we're able, and again, it comes from a trusted, certified source. However, they used a lot of internal labor codes, mappings that we had never seen, no one had ever seen, and it was effectively useless. So typically this isn't a problem because they would give us some sort of a decoder ring. They did not give us one. So we sort of had to just take this data as it was at face value. So what can we do with this data? Well, it's important to know what the context of your analysis is. So for us, this was a follow-on effort, meaning that we had bought some stuff from these people before. So we're able to look and leverage other data. So we're now out of the world where you only have one data source and it's terrible. Now you might have other data sets available to you. In this case, if you can find a better data set, you can just skip the data cleaning process altogether. And for us, we were actually able to use a previous negotiations data in lieu of this kind of crappy low level that we had. Again, low level is good, but not very useful if you can't map it. The other question to ask yourself is, who's the intended audience? So when you're looking and thinking about cleaning your data, if I'm getting data, and when I say cleaning, it's a very broad thing. This could be taking and stitching together data from multiple Excel files, databases, whatever. It can be pivoting, it can be transforming. There's a lot that goes into this, but for now, we're just going to say data cleaning as a kind of a whole term. So if I get data and I'm going to be passing it to a coworker, I know that they're data-driven. All my coworkers are data scientists. They like to dive into the data themselves. I'm not going to spend a lot of time cleaning. I might do some wrangling, but that's about it. Conversely, if I am going to be giving a brief or report to leadership, they don't want to look at a bunch of lines in a table. They want summaries, they want reports, they want answers. So sometimes if, again, you're just giving your data kind of as a working file to someone, you can more or less skip the entire cleaning process. And the last question is, when is your analysis needed by? Now, I know this is controversial. Good analysis should not be rushed, but fortunately, again, the real world, maybe you are in the middle of negotiations, the contractor comes back with a crap counteroffer, and congressional money expires in 3 days. This is not hypothetical. This legitimately happened. We were negotiating buying some engines, and in the middle of this, the contractor, or maybe it was even the government, honestly, I don't remember, decided that we needed to change how many engines we were buying, what year we were going to buy them in, how we were going to profile them out, all this sort of stuff. And we had 3 days to get a deal done with this brand new data update. Typically, this process would take days or weeks going back and forth with the contractor, with the engineers and the logisticians, trying to figure out what this impact would be and how we would want to fit that into our data. We didn't have time. So we just sort of had to guess and start just jamming it in best we could. In this case, excuse me, it's very important to document your assumptions. Because now when we took our newly mapped quantities, or again, the number of units we were going to buy, to the negotiation table, instead of having to talk about why the results the way they are, we could talk about these assumptions and get our conversation honed in on what actually matters much more quickly. All right, the final one I want to talk about is choosing the right algorithm. So I mentioned that I ran a simple linear regression on 3 data points for a $500 million deal. What I did not mention is that the R squared of that model was like 0.65. So we've got 1 degree of freedom, not a great R squared. So the obvious question is, why even use a linear regression in this case? Why not just do like an average of your 3 data points? That's a fair question. But to answer that, it's really important to understand the intent of your modeling. And again, I've got a few questions here that you can ask yourselves or make sure you can answer so you can defend your data and your analysis. And the first one is, what real-world effect are you trying to model? So for us, there's a few different things that we actually model, but it's generally speaking, how much are we going to pay for something in the future? The example I'll give is something called a rate curve. So who here in the audience has ever bought toilet paper? All right, if somebody didn't put your hand up, I'm a little concerned. I hope you have a bidet. But we've all bought toilet paper. And so, you know, if you go to Costco and you buy a huge 48 pack, or 48 equals 36, or whatever toilet paper math is, you know that it's going to be cheaper per roll of toilet paper than if you bought 10 rolls. In total, it's going to cost more, but your per unit cost is going to go down. We call that a rate curve. And we model it, not to go into too much detail, but by doing a simple linear regression in log space. So this is the real world effect that we're trying to model. And thankfully for me, the Navy has been buying things for a very, very long time. And there have been numerous white papers, studies, classes, or even textbooks published showing that this rate curve is, in fact, modeling the real world effect of this Costco effect, if you will. Now, obviously, not everyone is going to have the luxury of the US government sponsoring studies to say whether their model is good or not. But by understanding the real world effect that you want to model, you can, again, explain why it is relevant to what you're using and why it is useful, even if some of the results aren't great. Speaking of, why are the results what they are? So obviously, the follow-up question to what I just said is, well, Frederick, if there are all these great studies that show that a rate curve is in fact a good predictor of cost versus number of units procured, why do you get an R squared of 0.65? Well, that really comes from being an expert in your data, which again I mentioned earlier, and is really kind of the crux of this. So to illustrate this, let me give you an example. There was an effort that we were working on. We were buying wings for an aircraft, and we were getting some pretty terrible model metrics. Our R-squared were bad. We had some just general wonkiness. Our predictions weren't good. We were kind of just, again, using pretty bad data in this case, it would seem, but we weren't 100% sure why. So we looked into it a little bit more. And there was one point in particular that looked like an outlier. Now, I'm going to ask everyone in this room, what's an outlier in 5 data points? It's kind of hard to say. Like, what's 2 standard deviations from the mean of, again, like 3 or 5 data points? You can't really do typical outlier detection on these small of data sets. So we had to dive into the data and ask this contractor, hey, what was going on here? And the answer was that they were laying down carbon fiber, a technician dropped an oily rag, it caught fire, and a whole bunch of the wing had to be rebuilt. So it cost a whole lot more. So, okay, we now understand that there is some real world thing that occurred that is causing our model to not perform well. That doesn't necessarily mean it's completely useless, but it means we have to kind of understand what we're actually doing with that model a little bit more. So the final question for choosing the right algorithm is, how are these models that you're using being used and interpreted? So if you remember back on that first slide, there was one bucket in all of the different size data points that was 30 or more. And in that 30 or more, we actually have a few that are like 100, 200, 1,000 data points. And that typically is monthly or weekly labor data. So time series data for, Rachel who gave that talk earlier. So obviously this equally spaced out regimented data would be perfect for doing something other than just a simple linear regression, maybe some LSTM, maybe some ARIMA. And so we decided, hey, we've got this data, we've got the people who can do this, let's go ahead and try this as a pilot project. And we got surprisingly good results. We were getting model metrics that were outperforming our standard rate curves significantly. Doing train and test sets, things were looking great. However, when we started diving into the actual predictions, there were some weird things. For example, there were a number of months where it said that there were negative hours. And trying to convince a contractor that they owe you like 200 hours in the month of December in 2026 is not going to be very productive in negotiation and kind of doesn't really make sense anyway. There were some other issues, like if we were trying to account for inflation or escalation, how that gets factored in. But generally speaking, even though the model metrics said, hey, stop using the simple linear regression, use LSTM, use ARIMA, we had to understand how it was going to be used and interpreted. And really, for our use case, it just didn't make sense. So to kind of wrap everything that I've just talked about together into one kind of final closing trait statement, if the data doesn't speak for itself, you need to speak for it. By becoming an expert in your data and your analysis, you can understand when it's okay and why you should sometimes break some of those best practices and still use your models and your data, even if they're not perfect. And with that, I appreciate everyone's time. Thank you very much. And happy birthday to I saw you somewhere. I don't know, the 2 of you that didn't get sung to. Oh, and I better get that paper, Brandon. I heard that.